In this video, we're going to look at the second derivative test. And so the second derivative test, first off, what is it? Well, it is a test to determine the locations of extrema, maxima or minima. The second derivative test is generally easier, more direct than the first derivative test. However, it doesn't work in all cases. There is some restriction on it. So here's the second derivative test. If f of x is twice differentiable at x equals x naught, and the derivative evaluated at x naught is equal to 0, so we're at a critical point, then the second derivative being greater than 0 means that we will have, the point x naught, f of x naught, will be a relative minima, and the second derivative at x naught being less than 0 implies that x naught, f of x naught, will be a relative maximum. The second derivative test does not tell me where I'll have absolute maxima or minima. And before I go into an example, let me give a quick rationale for this. So if the first derivative is 0, that means that we have a horizontal tangent. If the second derivative is greater than 0, that means it's concave up. And so if we're concave up and we hit a 0 slope and we're concave up, you see this point here gives me a minimum. Similarly, if we have this horizontal tangent and we're concave down, then we will get a maximum. And so the plan is this. First, take the derivative and set it equal to 0 to find critical points. And then second, evaluate these to see concavity, and as such, classify the extrema. So let's see an example. Find and classify all extrema of this. So the first thing we're going to do is take the derivative, which will be 12x cubed minus 12x squared minus 24x. I'll set that equal to 0. And this is a nice one, it factors pretty easily, so I can factor out a 12x, and I'll be left with x squared minus x minus 2. This trinomial here factors, so I still have the 12x, and this factors as x minus 2, x plus 1, and so this means I'll have critical points at x equals, or when x equals 0 from this factor, when x equals 2 from this factor, and when x equals -1 from this factor. by plugging these in, since f of 0 is equal to 5, that's easy enough, I have the point 0, 5. F of 2, well, this is going to take a little bit more thought, so that's going to be 3 times 2 to the fourth minus 4 times 2 cubed minus 12 times 2 squared plus 5. 2 to the fourth is 16 times 3 is 48. Don't know why I'm starting with a 3 there, so 48. 2 cubed is 8 times negative 4 is negative 32. 2 squared is 4 times negative 12 is negative 48 plus 5, and that will equal negative 27. So this gives me the point 2, negative 27. And f of negative 1, I do the same work, so 3 times negative 1 to the fourth minus 4 times negative 1 cubed minus 12 times negative 1 squared plus 5. Negative 1 to the fourth is 1 times 3 is 3. Negative 1 cubed is negative 1 times negative 4 is positive 4. Negative 1 squared is positive 1 times negative 12 is negative 12 plus 5, and that equals 0. So this gives me the point negative 1, 0. And now I can finally actually do the second derivative test. I guess I could have done it here as well. So the second derivative is going to be 36x squared minus 24x minus 24. I put in the 0, so f double prime of 0 will be negative 24. The important thing here is it's negative. And so we have a critical point. We have a negative second derivative, which means it's concave up, which means we will have a relative max at the point 0.05. And I can do the second derivative evaluated at 2. And let's see, 2 squared is 4. 4 times 36, well, let's see, that's going to be 120, 144. So, 4 times 24 is 96. Let me do this. 144 minus 96 minus 24. And so, now this one, I can see that it's going to be, let me see, it's like 28. No, 24. Yes. But that doesn't actually matter so much. What actually matters here is the fact that this is bigger than 0. I didn't care that this was 24 instead of 28 instead of 18. What matters is this is bigger than 0, which means we're concave up, and that means we have a relative minimum, not mim, minimum at 2, negative 27. And I can do the same type of work for the second derivative evaluated at negative 1. So in here, negative 1 squared is 1 times 36 is 36. Negative 24 times negative 1 is plus 24. I have a minus 24. This is going to be 36. This is clearly greater than 0, concave up, which means we have another relative minimum at negative 1, 0. And the final thing before I look at the graph is this. I know from sort of pre-calculus that this function will end up looking like a W. That's a terrible W. Okay? And so up here, it'll just be relative. Okay? It won't be an absolute maximum because it goes higher on both sides. However, one of these two, or if they're the same level, both of them will be absolute minimum. And in here, we can see this value is lower than that value, so this is relative and absolute minimum here. Alright, before we go on, or before we end this video, let's just look at the graph to see that it all works out. So here we have it. You can see this point here is a relative minimum at -1, 0. You can see this point here is a relative maximum at 0, 5. And then way down here is a relative minimum at 2, -27. I hope this helped out. Feel free to comment below if you do have any questions.